right over here is soaking in water.
Yep.
Wet burlap.
So this is very low tech right here. We're going to mix all three of our matrices, and we'll have cardboard, wood chips, and straw growing in buckets with burlap sheets in between.
What does the burlap do?
The burlap, it provides a horizontal surface for the fungus to grow on, and it likes interweaving itself through the weed.
So the structure of the burlap sac encourages mycelium growth?
The physical structure of the burlap sac encourages mycelium to run.
Yeah.
And when it's in a situation like these, where they have holes on the bottom, they get to breathe. And if we put a little bit of weight on top of it, it keeps everything from moving around and it gets colonized even faster.
There's a lot of mycelium around here.
Yep. There is King Stropharia mycelium, there's Bluet mycelium, there's Sathurella, there's Schizophilum commune mycelium.
What are we working with today?
Today we're going to work with Namiko and another one.
So we're going to take that Namiko spawn the bag spawn?
That from the pictures and the mushrooms that you guys ate.
Yeah, and we're going to mix that in.
We're going to mix that into buckets using this
medium
matrix.
Mm-hmm. So the three-part matrix, again, is a straw, burlap,
cardboard, wood chips, and burlap. Actually, it's a four-part matrix.
Yeah.
I can't count.
That's right.
Numbers aren't my thing.
Is this cold pasteurization?
This is a cold pasteurization method. So it's not really being pasteurized, but it's being soaked. So we're going to see how Namiko responds. We're going to see if it does anything like Oyester. Oyster responds really favorably to a cold pasteurized straw.
The process.
And
Now, this is a low-tech method as opposed to pasteurization, which would actually be sterilizing everything first, so that you would really be sure that you had one dominant strain of mycelium. Whereas, like the oyster, one of the oysters we did was a Caprinus.
Right.
Is that was like, so there was like a stronger.
Let's go ahead and show that one.
Matt, you want to grab it or grab it? Yeah. So that was something we cold pasteurized. It was oyster, right? It was inoculated with oyster.
Yeah, that was a project that was cold pasteurized. We inoculated it with oyster, and sometimes they don't go right. So when they don't go right, this one kind of had these coming up in it. So take a picture of these dots. You see those dots there? When you look,
should take a picture too, because I can't get a close-up of the video. So
when you look at your compost projects or your mushroom projects and they have these white dots, it's a sign of Caprinus lagopus contamination. So you can see them in several different places. These are a good mushroom to have in your yard. They promote good fungal decay and decomposition, but they can also be a competitor. And this is what happens when they get wet. They get things black.
Yeah, but this is really good to put in our compost, and we're going to inoculate our humanure.
Yeah, and this is Caprinus is a coprophilic species, which means that they like to eat manures and poo. So this one might be a good candidate for mitigating or decomposing some of the humanure that's been composting here. And the bees love it. It provides a carbon-rich source that they'll actually suck out of mycelium. So
very cool.
What I'm going to do is I'm going to put this here for now. And then these are other, I don't know if we should videotape these because this shows panning.
This is good. I mean, it's good to know what this is.
Okay, so let's go ahead and take this one out. So what panning is if you can get the surface, it's all kind of like homogeneous.
It's kind of compacted too.
It's compacted. Panning is the mycelial growth is so thick and the colonization is so thorough that it doesn't allow water to come in.
Too thick?
Yep.
For fruiting.
For fruiting. But we can make this up and we can spread it around to different projects.
Can you loosen it up, or is it how it grows is not really...
If you loosened it up, it wouldn't, I don't know. I mean, it's pretty tight.
It smells amazing.
Yeah.
I love that smell.
So we'll inoculate something with this.
So some of the stuff we've been soaking down, that's oyster.
Yep.
So that's quite a cache of mycelium right here, though.
There's some good mycelium in here. And then here's some of the patterns it shows, where it reaches out.
Oh wow, that's crazy. That is really cool.
Oyster mushrooms, they grow on probably the widest variety of substrates. They grow on hair, they grow on books.
Coffee.
They grow on coffee grounds, they grow on dirty cotton diapers. They grow on flour, on coffee and chocolate wastes.
They ain't picky.
They are not picky, they're one of the most proliferous recyclers of nutrients, of natural materials in the world.
And then they do the whole detox thing.
And then they detox. The acids they secrete from their mycelium at the tips are so powerful they can break down a wide variety of pollutants.
And it's true, like as Paul Simon says, they actually break those hydrocarbon bonds.
When you break those bonds, it releases tiny amounts of oxygen, nitrogen, and carbon into the soil, and that starts a biological chain. Other remediation strategies have used stuff similar to that. They'll put iron in the soil or all kinds of things. They'll like lay a pipe into dirt that's contaminated with oil, and they'll pump oxygen through the pipe. And just a little bit of it gets it going.
So how long should we soak this stuff for? Or
We're just going to soak this for about an hour.
Okay. So then the next stage would be, we'll just wait for this, and then we're going to start mixing in the mycelium and, okay.